Okay, so we're talking here about what happened if we put an ammeter in the wrong spot and we determined that it would do what? It won't work well. All right. So, because an ammeter has very high or very low resistance?
Very low resistance.
Very low resistance. But yet, I do see a lot of this still. Measure the total current flow of the circuit. Hey, no problem. Current flow, circuit. Well, I can just do this. And then you wonder what happened to the fuse. Now, if you have enough other resistors, you'll be safe and won't blow the fuse probably. But what happens if you mess up in this manner? And you put the voltmeter in here. Does that change the circuit at all?
No. Yeah. No.
It's totally fine. It affects it a lot. Why does it affect it a lot?
Has high resistance.
How much resistance does it have?
20K resistance.
A lot. All right, so we don't do that. So, all right. Well, that's kind of talking about a voltmeter. Let's talk here about an ammeter specifically. Ammeter. Ammeter measures what? Measures current flow. And if you say voltage flow, I'm not gonna accept that. So don't, when you talk about voltage, we don't talk flow, right? An ammeter. An ammeter works on the same principle as a voltmeter. The exception is that an ammeter is connected in what? Series. So all the current flows through it. Did all of the current have to flow through the voltmeter?
No.
It only robbed a little tiny bit to do what? To run what? Voltmeter. When I hooked the voltmeter up to the circuit, did it take a little bit of current away from the circuit?
Yeah.
What did it use that current to do? It ran the needle, caused the needle to deflect. Well, now I'm going to take all of the amperage and I'm going to run it through this little needle. All of it has to run through the meter, right? So like when you get to the battery project and you're measuring close to 10 amps, you think you want to put a little 10 amps through that little tiny coil that a minute ago was using 50 microamps? Now I'm going to run 10 amps through it. How is that going to work out? Well, it works. How does it work? For very small amounts of current. Just magic.
That better be one of the questions on the...
Well, that's what I said earlier. The entire thing about electricity is it runs on what? Magic smoke. And if you let the magic smoke out, it quits. Let's see. Very small amounts of current. The internal coils. And what coils am I talking about?
Needle.
Of the needle, yeah. Okay. The internal coils can handle the load. It's not a problem for very small amounts of current. All right. For currents And I'll put it this way because I think I had a hard time finding a consensus. So I'll say 10 milliamps. So anything for currents, say 10 milliamps. Currents over, say 10 milliamps. There we go. A shunt. A shunt is used. What is a shunt? Like shunt up, shunt the front door.
Yeah, you heard that?
Drain excess.
A drain.
Drain excess of something.
There we go. We're talking medical use, right?
Yeah.
Shunt. Shunt simply means parallel. That's it. Just means parallel. So why do you think they didn't write parallel?
Way too simple for these jokers.
That's right, because shunt is easier to spell. It's easier to smell. I can smell it. Never mind. In this case, a parallel resistor is used. All right, so you got to have a resistor that's going to drop the current away from the meter. That's what I want to say. So I wrote, think of a shunt as a bypass in this case. Not always, because later on we're talking about shunt wound motors. Shunt wound motor, what is that going to mean? Parallel wound versus, what would be the opposite? Series wound. So, yeah.
So is that going to affect your reading then?
Not really. Very little if it's done right. And I'll show you that. Let me see. Put it. Let's see. Consider, this would be an example, an ammeter that requires 0.01 amps to make a full scale deflection. And has a 5 ohm needle movement. What in the heck does that mean? I think I have a drawing. What does the 5 ohm needle movement mean? Silence? Where's my Cricket app?
Movement, that's
So that means
use 5 ohm. Yeah, I mean, have 5 ohm as resistance.
Say it again.
The movement that's moving the needle.
Uh-huh.
Has 5 ohm.
Okay, all the little coils that are wound that make the needle move come up to 5 ohms. Okay, so how many volts then does it take to make a full scale deflection? Well, how can you figure that out? Oh, I know. Have I mentioned Ohm's law?
I don't think you mentioned that.
I have 5 ohms, 0.01 amps, so the voltage drop across it is going to be 0.05 volts. All right. So what was I going to say? It takes 0.05 volts to create a full scale deflection. So I already know it takes 0.01 amp. It's got a 5 ohm movement, so it's going to have a 0.05 voltage drop across it. And I said, okay, let's just say, say 10 milliamps. Am I within my 10 milliamp range? The meter's okay? I'm not going to burn up the coils? Okay, so if I had an ammeter like this, and and I have to measure a circuit that's only got 0.01 amps to it, am I okay to use a meter with this particular scenario?
Yes.
Say yes. Okay.
Yes.
Now, what if,
Oh boy.
what if
This is where they get you.
we need to measure 30 amps with this same meter?
Better change scales. Maybe the main meter.
I want to say I had a good drawing of this one. Let me see. Is this it? Nope. Ah, that's what we're talking about. We're looking at something like that. So we got 5 ohms of resistance. We got to figure out what kind of resistor here. So if we add a resistor down here, then what happens is the resistance is going to have a big voltage drop here, leave only that little tiny voltage drop here. And I want to say that differently. It's going to cause the current to flow this way instead of this way. So we can only have how much current flowing through here? About 0.01 amp. So all the rest has to go this way. So we have to make something to go across here. Well, could we just put a straight wire with no resistance? We could. We've got, what, an ammeter here? Is it going to bother anything if we have an ammeter that's dang near a short circuit? Let's go back here. Well, I don't know. If I have a battery and a resistor and I put an ammeter, is there much resistance to the ammeter anyway?
No.
No. So would it really matter if I had this over here? Let me see. Let's go full screen. Oops, from current slide. There we go. Would it really matter then if this was just a straight wire?
No.
In fact, in our first example, where we were only measuring 0.01 amps, this was open, and all the current went this way. And if I put just a straight wire across there, where would all the current go? You guys falling asleep or don't get it? Oops. Pen. If I just put a straight wire here, no resistance, what's going to happen?
It's going to mainly go across that wire instead of...
Okay, so it goes through this wire. So what?
Short.
It's not really...
It's short. Does it affect the circuit?
No.
You wouldn't be reading the amperage. Because it'd be going through.
Is an ammeter right here that just shorts out going to affect my circuit? Is it going to blow a fuse?
No.
I'll put a circuit
Not
breaker.
gonna read anything.
There you go. I'm not going to read anything.
Yes.
Because why?
Just come
'Cause-
straight to the meter.
Because pretty much all the current would come through and go, hey, let's go this way. And maybe a little tiny bit's going to go that way. Just adventure seekers. All right, so it's not accurate. It's not going to work. So we got to have some through here. All right, so let's go back here. All right, so what if we want to measure 30 amps? How are we going to do that? We got to figure out what that resistor's got to be. Yeah. So if, how much should, what's the max that can flow through the needle? 0.01 amps can flow through meter. Well, then, how much has to flow out around the meter through the shunt?
29.99.
29.99 what?
Percentage
Amps.
Amps. Is anybody lost right now? Like, I don't know what's happening?
Yeah.
Okay, it's basic Ohm's law we're talking about. Oh, that didn't help, did it?
He's talking about the ohms.
Let me go back. Oops. I'm saying, and what we're doing here, number one, we're looking at meters, but number two, we're exercising Ohm's law. You can't just keep doing simple series circuits over and over with 4 resistors. Life happens. All right? So I've got, you're thinking, I can too. I was fine doing it my whole life till I got here. All right, so I've got 30 amps is coming in here. How much can go this way? 0.01. Why? Why can only 0.01 go through there? It's going to give me a full scale deflection. Who said it's 0.01? I did. It's a number I made up based upon how meters work. All right? So 0.01. So then how much amps has to go this way?
29.
The rest of it. All the rest. So 29.99. 29.99 plus 0.01 equals 30. So 30 amps are going in. All right. So we know we got that. What size should this be?
Tell us our voltage, Kevin.
Tell us your voltage. All right.
Oh, you said 0.05.
We know that the meter is 5 ohms. And what was 0.01? So what's the volts? 0.05 volts. All right. So we got that much. What kind of circuit is this? Parallel circuit. Okay. So right there's my meter movement. Right there is my shunt. So this is the meter. This is the shunt. Okay. So if the meter is got that, what do you suppose I can say about the shunt right now? What do we know about it?
We know.
Same voltage? What are you, crazy? Where did you get this idea from?
Shunt the front door.
Yes.
I'll say Ohm's law, Kevin.
Because it's a parallel.
Because it's a parallel.
Because it's parallel.
Oh my God, the light guys are like, wait a minute, I know this. Because it's a parallel circuit. So what can I know about this parallel circuit? It's 0.05 volts.
Yes.
All right.
Excited.
If you can't see that, I've got some pamphlets for trucking school. But no. Models application. No, it's okay. You'll get this. All right. Lights are. I know your lights are coming on. Some are a little dim right now. There's some resistance going in there, but it's a variable resistor. I know everybody in here can get this. It's a parallel circuit, right? You just got to think it through. It's a parallel circuit. Just simplify it. So I know that in a parallel circuit, the voltage across R1 is the same as it is across R2. So that's just 0.05 volts. Well, I still don't know the resistance. That's what I'm trying to find out, right? Whoa. Now I got to have one other thing. What else can I figure out? The amperage. Didn't we already get that?
Yes, we did, Kevin.
I told you right there. 0.01 is going up through the top. What's left over?
29.99.
29.99 amps. So how much should that resistance be?
Well,
Well, shoot. If there was some sort of formula that we could use to do this. If I haven't mentioned this before, E equals I times R. I know you may not have heard that before. So I may have mentioned it last week. So E is 0.05, and I want to find R, so it's divided by 29.99. It's not even a milliamps or anything. It's just 29.99. How simple could it get? It is 0.001667222. I think everybody should go to the tool room and ask for that.
That would make James happy.
Let's just take a guess.
What are you kidding? That guy,
Oh, look at that.
that guy didn't even show up. I don't care.
Kevin,
Be nice.
what I'm confused on is how are you going to get an accurate reading if 29.99 amps isn't going to the coil?
It's bypassing it.
Okay, but
It's bypassing it. Okay, so I can see what you're thinking here. So let's think like the guy who made the meter. Okay? The guy or the gal. It's actually probably a girl. I'm not. That's not. You guys know about the computer women who actually sent the Apollo. Yeah, it's actually not the best book, but it's a great history. They did all the thinking. Well, all the men sit around and smoke cigars and did, Anyway, so Okay, so the guy who made the meter says, you know what? I am going to make a meter, and I'm going to put on it, I'm going to put a 30 amp spot on this meter. And so I switch it to 30 amps. So I can measure 30 amps now. And so what is full scale deflection going to be? I'll give you a hint.
50 amps.
What's full scale deflection going to be? How many amps?
30 amps.
30 amps. So the person who did this, when you switch it, it's going to have a resistor that's going to now line up. This makes it look like it does it. There's a little monkey inside of there, and he's got a rack full of resistors. And when you switch it, the little monkey, is it a monkey? What kind of animal would be inside something else? What? A little ferreters. That's why the meter's box is big. Goes in there and he pulls out the little .00167 resistor, and he plugs it in to this little spot right here. So you got to wait a minute before you use the meter. That's why you're not supposed to switch under a load, because the little critter in there can't move him that fast. So the little critter moves out, and he puts the .00617 and says, you're good to measure up to 30 amps. And so you, being you say, well, if I can go up to 30, I'm going to do 30. And so you do it. You stick it in there, and you measure 30 amps. So what happens? 29.99 of those amps are going to go through here because of Ohm's law. 0.01 is going to go up through here. And because 0.01 gives you a full scale deflection, it's going to go all the way to full scale deflection and read 30 amps.
Good thing I was actually measuring 31.
If you're measuring 31, then it
The
gets,
monkey's pissed.
yes.
Biggest pride.
All right.
Monkey.
Looks like
Follow?
Once you started explaining it,
Once I personify it and started using monkeys, everybody seems to get it.
I got it now.
I actually explained, who's in my carburetor class? Did we do the carb monkey this year?
I was building the carburetor on the island.
Did that work?
Yeah. It did.
Some years I get it better than others. This wasn't one of my better years. Okay. Now you figured that all out. That's great. So we just figured out, okay, and so the person who made this meter, they got the 30 amp done, and then they went on vacation. And they left us in charge of figuring out how to do 3 amps. Oh yeah, I want my meter to have a 3 amp scale, going on vacation, see ya. So now we got to build one that has a 3 amp scale. How are we going to do that?
Well, you know your full scale.
Need a resistor.
Well, some things are still a given.
Whoa.
Get out of town.
So parallel resistors. I have to make them parallel. All right, so there's the meter. All right, just so you guys can not freak out. I'll kind of. All right, there we go. What can we fill out here? What do we know?
You know that the meter is 5 ohms.
Meter hasn't changed.
Oh.
It is if I write that up.
It's about to change.
All right.
Resistance is 5 amps.
All right, so that hasn't changed. What else is the same?
0.01 amps is full deflection.
All right, so 0.01 amps is full scale deflection. So 2.5, 2.0, 1 point. So this is what the scale is going to look like now, right?
2.99.
I could have just put the point in there. So all right, that's what the scale is now. So what is E going to be? 0.05 volts. Why? Because of Ohm's law. So everybody see that? Where's the 5 come from? That's where we started. Where did it come from?
Your resistance, Kevin?
The resistance of the coil.
Right there. It's a given. Where did the 0.01 come from?
Full scale
Full scale.
It's a given. It's in the writing. It's in the description. Hey, it's got a 0.01. Then where did 0.05 come from? Ohm's law. Okay. Parallel circuit. So Ohm's law down here, what do we know? 0.05 volts, because that doesn't change.
Needs the rest. So it's
Do I know the resistance?
Nope.
No, you know the
Amperage
amperage.
is 2.
Well, how do I know the amperage?
Cause it's
Because
whatever.
3
what that
amps is
can
the
take.
max, and you have 0.01 amps.
Because it's
on
3 amps.
the
So if in a parallel circuit, if I should use green. If 0.01 is going this way, 0.01 amps, and this is 3 amps, 3 this way, what is then going this way?
2.99.
2.99. Okay, so 2.99. 2.99 amps. Wow, that just couldn't get a whole lot messier. And then I bag on you guys for being messy. Okay, and so what is my resistance? That's what the question was. Have I mentioned Ohm's law? Okay, so what is my resistance going to be?
0.0167.
How do I get the answer? What is the answer?
Divide it, Sean.
Divide what?
E divided by I.
E divided by I. 0.05 divided by
2.99.
2.99 equals
A number.
the number.
0.0167.
0.0167.
2. Keep going. 2.
I'm done.
4,
I ran out of room.
0, 8.
All right. That's C. That's going to be B on the answer. Trust me. I made that up. All right. Don't just pick B.
I just made a note.
Anyways, so-
All right. So is that?
Which number is that, Kevin?
Yeah. You want me to do that one more time? It's on the test.
Yeah. Which number is it?
Let's do it with 10 amps. Or on
Can I
one
just do
amp.
Christmas trees and pass?
Let's just do the numbers that I thought of already, so I don't have to really think on
Just
it.
gonna
All right.
just gets beat.
Mr. Vacation called in and said, "Hey, while you're at it, I want a 60 amp scale."
Oh, you know what? I think I'm going to go on vacation.
Whoa, what happened here?
I'm going on vacation too then.
Hey, yo.
All right, 60 amps. What are you going to do?
Well, you know your resistance top is 5 ohms. You know full scale is 0.001.
I'm just going to simplify now.
9 amps.
You know you need 60, so it's 59.9.
This is one of those things where if you're sitting there going, "I don't know what he's talking about, and I sure hope that this isn't going to be on the test," you're not going to be happy.
Well, like how many questions is on the test?
7, enough that you'll fail.
I know the whole test is like this. It's not that hard.
This is easy. This is actually very easy. Once I show you how to do it, you should just go, it's just Ohm's law. Again, it's really nothing more than we did last week. It's just given to you in a different way. You just have to look at it and think about it.
Once you told me there were monkeys involved, Kevin,
You were all
I was
over.
game.
Okay.
I came out of the drawer with
Now, of course, I would have to tell you that 0.01 amp equals,
full scale.
Full
It says
scale.
it right at the top.
oh, jeez. Thank you.
Good job, Kevin.
Thanks for helping out. My job just got easier. I'm just going to go home and let you finish this.
All
All right.
let's clock out on your way.
0.01 amps. So again, so E is what? How did I find E? E equals I times R. So I times R. So I got to do it 5 times
Still 0.05.
0.01. I'm just making sure it hasn't changed. 0.05 volts. All right. So what is my resistance here? Is it somewhere on here? Oh, it must be that.
No,
No, that's not even the right answer.
No, but you know your amperage and your volt.
I don't know the amperage. I do know the amperage.
We don't know.
But I know this. It's 0.05 volts. It's 0.05 volts. Why? As it's parallel. I'm hearing more and more people. You're coming online. This is awesome. Okay.
It's almost time to go.
The current is what?
59.99.
59.99 amps. So therefore the resistance is? Oh, I don't know if I can follow all that.
0.83.
Oh, 3 zeros.
And 8, 3, 3, 4, 7, 2.
You sure it's 3 zeros?
I hear it,
Point zero.
0.05
472.
divided by 59.99 equals 1230. Okay. Ohms. There we go.
Kevin, if this guy calls one more time.
With what? All right. I'll make a few more points here before we. Just because it bears repeating. E, F, G, H. Examples. H was all of the examples we just did.
That you needed to put that.
Oh, H through H, yeah, because H through I actually were examples. H, I, now I'm on J, just because you want to know what I'm doing. And ammeter has very what resistance?
Low.
Very low resistance. And is placed in what?
Serious. Full in parallel.
With the load. Series is the correct answer. If you decide to use an ammeter to measure how many amps a battery has, how many amps will flow through the ammeter? All of them. Very rapidly. And what will you do next? You will replace the fuse. Well, you don't always have to. How can you get around replacing the fuse?
Probably more resistance.
Anybody know the answer to this
Put
one?
a piece of wire in there.
Use a aluminum foil
Circuit
gum
breaker.
wrapper.
What?
9mm shell.
A tiebreaker?
Circuit breaker.
Circuit breaker. I believe if you put it on the 10 amp scale, well, I do know you have to pull both of the,
Yeah.
put them up at the top. That's the 10 amp. I believe the 10 amp is not fused.
Really?
Yes.
So you can just melt the wires.
So you just have at it until a little puff of smoke. And then you won't have to replace the meter. You just have to replace the,
Fuse.
no, you don't have to replace the fuse, you have to replace the meter. There you go. All right.
We still didn't get that.
But the fuse is like $5.
Oh, I stopped. Okay, so because of the low resistance,
I'll just buy another monkey.
That's like.
Then you buy it for
because of the low resistance, if placed in parallel, what's another name for parallel now? I'm going to say all the current. It's technically not correct because I believe there would be a small amount of current that would still go the right way, but it's close enough to all the current. Will, I'll say want to flow through the what? Gosh, I lost you again. Through the meter. Because of the low resistance, if placed in parallel, that is the meter placed in parallel with the load, all the current will want to flow through the meter.
You can tell by actually after you hook up the meter in parallel, you just put another one in series, and then you can see how much.
There you go. You'd watch it drop, wouldn't you? But you have to get a new fuse, and so check it quick. Use your neighbors. Basically,
Can you do it?
installing a meter
I'll show you on your meter for you.
in parallel with the load will what? What will it do to the load? Come on, what's our
Bypass. It will
bypass?
Shunt the load.
You'll what?
Shunt the load.
What?
Not shunt the load. You're not wrong. That's not the word I'm looking for. What will it do? Installing a meter in parallel with the load will do what to the circuit?
Fine.
Short.
Short it out. will short out the circuit. So don't do that. Or short out the series that you connected it across. So it's, we have one load, and I put an ammeter. It's kind of like just putting a wire like that. Is that a good thing? No.
Depends on the day.
Yeah. It depends on the battery size. If it's a, if it's one of the 12-volt batteries that we use for starting aircraft, it's definitely going to make the wires very red hot and melty. See, here's the thing though. When you do something like that and you accidentally clip something across a real battery that's got some significant potential, like an aircraft battery, once it's clamped on, it turns red hot so fast that there's nothing you can do to get it off.
You just cut it
It
with
welds
knives.
itself to it.
It welds itself, yeah.
You know what? That's a good experiment.
No, I did that 2 years ago.
Did you?
So when you guys are working with your batteries, you're going to get a bunch of clip leads. One of them has been burned pretty bad. So we've got a special board that runs off a 12-volt battery that will allow you to look how logic circuits work. It hooks up to a battery, and there was something on the back, and I turned it over, and the clip leads came undone, and one flipped over and shorted out the battery, and it just smoked instantly and just burned it. There was very little I could do to get it off. I think I just had to yank it because it was not something I could grab within just a portion of a second, and it was done.
Would that be micro or milli?
I don't know. The poo came out, and the whole lab smelled
That's
so
peak.
bad for the entire day. And then we walk in. What happened? I don't know.
New students.
Students, you know what are you gonna do?
Try dropping a wrench on battery.
All right. So now we can talk about. I feel like we're talking ohm meters. So we'll do a section on ohm meters. Yes, number
Don't
7.
even worry about why.
It just is. Don't.
It's
You can
all-
see it on my paper. It makes sense
It's
because
all shunted.
it's.
Exactly.
I'm gonna do so.
All right. We can do some more fun with Ohm's law.